Hello students, today I am going to discuss the fourth part of the chapter solution, that is Henry's law and its applications. As in the previous video, I discussed the topic solubilities of gases and liquids. So the solubilities of gases and liquids depends on a law, and that law is known as Henry's law. Now let's see what is Henry's law states. Henry's law states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. It means the solubility of any gas in a liquid solution is directly proportional to the partial pressure of the gas, which is present above the surface of the liquid or a solution. It means suppose we have a beaker and in the beaker this part is liquid phase. Here liquid is present in the beaker and the gas which we have to add in the liquid is above the liquid surface. Now, as above the gas, there is a piston and which is a movable piston. And as we applying pressure on the piston, the gas will move down towards the liquid. And what will happen? The gas molecules which are present at the surface of the liquid. The gas molecules which are present at the surface of the liquid will get dissolved in liquid. And as we increases the pressure, the gas molecules will slowly dissolve or slowly soluble in liquid solution. Now, so that the Henry states the solubility of any gas in a liquid, solubility of a gas in a liquid is directly proportional to the partial pressure of the gas which is applying. And the gases will dissolve which is present at the surface of the liquid or a solution. This is Henry's law. At the same time, when Henry give his statement, at the same time Dalton also concluded that the solubility of a gas in liquid solution is a function of partial pressure of gas. It means Dalton also suggests that the solubility of a gas in a liquid solution is a function of partial pressure of gas. Now, if mole fraction of a gas is act as measure of its solubility, suppose mole fraction is taken as a measure of solubility, then what will happen? The mole fraction of a gas in the solution is proportional to the partial pressure of the gas. When mole fraction is taken as the measure of solubility, then the mole fraction of a gas in the solution is proportional to the partial pressure of the gas over the solution. Now, from this, the Henry's law states that the partial pressure of the gas in vapor phase, partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. It means from the above conclusion where the solubility is taken, where the mole fraction is taken as the measure of solubility, Henry's law states that the partial pressure of a gas in vapor phase is now proportional to the mole fraction of the gas in a solution. Now, according to this definition, we can write partial pressure of the gas, that is P, is directly proportional to the mole fraction of the gas. It means when mole fraction is used as a measure of solubility, now partial pressure is directly proportional to mole fraction. So this is Henry's law. Now, if we remove the proportionality sign, then a constant will be added there. And what is that constant? That constant will be Kh. Now, the equation will become P equal to pressure, partial pressure P equal to Kh into X, where X is mole fraction, and the Kh, the new term which is added after removing the proportionality constant, this Kh is called Henry's law constant. This Kh is Henry's law constant. Now, Kh, this Henry's law constant, is a function of nature of the gas, since different gases have different values of Kh at same temperature. When the temperature is same, the different gases have different values of Henry's constant. The higher the value of Kh at a given pressure, the lower is the solubility of the gas in the liquid. Now, from the formula, we have P equal to Kh into mole fraction X. Now, according to the formula, if higher the value of Kh at given pressure, suppose we have higher value of Kh at given pressure, the lower is the solubility of the gas in liquid. Why it is so? Because because Kh, Henry's constant, on rearranging the above formula, Henry's constant Kh will be equal to P upon pressure upon mole fraction. So, higher the value of Kh, if the value of Kh is higher, then the mole fraction will get decreased, and we have already studied earlier that mole fraction is a measure of solubility. It means if value of Kh is higher, then the solubility of a gas in liquid will get decreased. Now, mole fraction of a gas in a solution is proportional to partial pressure. According to the formula, mole fraction of a gas is directly proportional to partial pressure of the gas. Now, on drawing graph between partial pressure and mole fraction, we will get a straight line. On drawing graph with partial pressure versus mole fraction, we will get a straight line. Why? Because partial pressure is directly proportional to mole fraction of a gas. Come to limitations of Henry's law. Henry's law have some limitations. What are those? First limitation is the temperature should not too low. The temperature on which the gas is dissolving to the liquid, the temperature at this time should not be too low. Now, second limitation is pressure should be low. Condition is there that pressure should be low. If the pressure is high, then at high pressure the law becomes less accurate. If the pressure is high, then at high pressure the law will become less accurate. And the proportionality constant shows considerable variations. Now come to the third point. The gas is not highly soluble. It means the gas we are using or we are dissolving to the liquid, that should not be highly soluble in the liquid. Now come to the fourth point. Fourth limitation is the gas neither reacts chemically with the solvent nor dissociate or associate with the solvent. The gas should have the characteristic that it neither reacts chemically with the solvent nor dissociate or associate in the solvent. This must be the characteristic of a gas which we are using or which we are dissolving in a liquid. So Henry's law have limitations. It means a gas should obey a ideal gas equation, or a gas should obey a ideal situation. Only then the Henry law will be applicable for the solubility of gases in liquids. Now come to the next part, that is application of Henry's law. Before coming to the application, we have to understand about the law. What is Henry's law? Henry's law is when we increase the pressure. This is the first picture. When we increase the pressure, this is the gas part. These are gases. These are gases molecules. As we increase the pressure, the gas molecule will move towards the liquid part. This is liquid part. Henry's law states, Henry's law means when we increasing the pressure, when we are increasing the pressure, the gas part will move towards the liquid. And after moving the gas to the liquid part, an equilibrium and stage a stage reached, that stage is known as equilibrium, or a saturation point will be there. When gases start dissolving in liquid, then a situation develop, and then that situation is known as equilibrium situation, where the saturation of the gases molecules will take place. Now, now come to the third. As we release the pressure, as we are releasing the pressure, then what will happen? The gas will move out from the liquid. It will move toward it will move outward side. If we are applying pressure in a beaker, then the gas will move inside the beaker, and in second picture, a situation came which is known as equilibrium stage. A stage came which is known as equilibrium stage, where the saturation takes place. And as we are releasing the pressure, in third picture, as we are releasing the pressure, then what will happen? The gas molecules will move out from the beaker, will move out from the liquid, and they will escape. So this is all about Henry's law. Now come to the applications of Henry's law. Applications of Henry's law. First application of Henry's law is applicable in the production of carbonated drinks. Now, see, to increase the solubility of carbon dioxide in soft drinks and soda water, the bottle is sealed under high pressure. As to produce soda water or soft drink, the carbon dioxide gas must be added to the soft drink bottles, and the carbon dioxide gas is added by applying high pressure to the bottles, and the bottle is sealed under high pressure. Now, when the bottle is opened, when the bottle is opened under normal atmospheric conditions, the pressure inside the bottle falls to atmospheric pressure. The pressure which is very high under the bottle will falls to atmospheric pressure, and the excess of CO2 bubbles out of the solution, causing the effervescence, come out to the solution and causes the effervescence. Now, सोडा बॉटल्स में हमें गैस फील करने के लिए, हम जब CO2 गैस सोडा बॉटल्स में जब हम फिल करते हैं, तो हम उसे क्या करते हैं? अंडर हाई प्रेशर गैसेस को फिल किया जाता है, एंड जैसे ही वो हाई प्रेशर, जब हम उसका कैप ओपन करते हैं सोडा बॉटल्स का, मीन्स जब वो जो प्रेशर बॉटल के अंदर था, उस प्रेशर को जब हम बॉटल के अंदर से बाहर ला रहे हैं, मीन्स जब हम उसे एटमॉस्फेरिक प्रेशर में जब उस कैप को ओपन कर रहे हैं, तो होता क्या है उस टाइम पे? जो CO2 के बबल्स हैं, जो हमने फिल करी थी कार्बन डाइऑक्साइड गैस, वो जो गैस है, वो लिड ओपन करने में वो गैस क्या होती है? बाहर की साइड को मूव करेगी बॉटल से। बाहर की साइड को मूव करने का मीनिंग है एफरवेसेंस कॉज करेगा, और वो जो एफरवेसेंस है वो इन द फॉर्म ऑफ फिज बाहर आती है. So this is the application of Henry's law. Henry's law is applicable in filling carbon dioxide gas to the soda water or soda drinks bottle. So this is how the gas can be filled to a liquid part. Now come to the next application of Henry's law. Henry's law is also applicable in scuba diving. Scuba divers must cope with high concentrations of dissolved gases while breathing air at high pressure underwater. And increased pressure increases the solubility of atmospheric gases in the blood. As scuba divers start moving underwater, then what will happen? The pressure increases as they move deeply, as they move deep underwater, the pressure increases. And on increasing the pressure, the solubility of atmospheric gases in the blood also gets increased. As the pressure increases from the upper side, then the solubility of atmospheric gases also get increased in the blood. Now, what will happen? You can see this in the picture also. As the scuba divers start moving inward to the water, then what will happen? As he enters to the water and he move deeply to the water, the pressure will increase. As the pressure increases, the atmospheric gases which is present in the water will start soluble and will start soluble to the blood of the diver. Now, as the atmospheric gases get soluble to the blood of the diver, then at a stage came when all the atmospheric gases were start solubling, or all the atmospheric gases are dissolved in the blood of a diver. Now, as when the divers come towards the surface, when the divers come towards the surface, the pressure gradually decreases. Underwater, the pressure is very high, but as he came towards the surface, the pressure will get decreased. And this releases the dissolved gases and leads to the formation of bubbles of nitrogen gas. Now, as the pressure will get decreased, then the gas will move out from the blood. As the gases will move out from the blood, and it will lead to the formation of bubbles of nitrogen in the blood. And this blocks the capillaries and create a medical condition. The bubbles of nitrogen creates a blocks in capillaries and create a medical condition which is known as bands, which are very painful and dangerous to life. Now, to avoid such bands as well as the toxic effects of high concentration of nitrogen in the blood, the tanks of scuba divers are filled with air diluted with helium, because helium is an inert gas. So the tanks of scuba divers are filled with air which are diluted with helium. In their tanks, there is 11.7% helium and 56.2% nitrogen and 32.1% oxygen gas is present. Now, so this is how the Henry's law is applicable in scuba diving. Now let's see the next application of Henry's law. Now come to the third application of Henry's law, that is at high altitudes. At high altitudes, the partial pressure of oxygen is less than at ground level. As we all know that at higher altitudes, the pressure of gas gets decreased as compared to the ground level. Now, what will happen due to the decrement of partial pressure of gas at higher altitudes? This leads to low concentration of oxygen in the blood. As the partial pressure of oxygen is less at higher altitude, this will leads in low solubility of oxygen in the blood. Why it is so? This is because of Henry's law. As Henry states that the partial pressure of a gas is directly proportional to the solubility of a gas, and as the pressure becomes low at higher altitudes, then the solubility of the oxygen gas will also get decreased. and due to decrement in the solubility of oxygen gas in blood or tissues of the human being which are living at higher altitudes or in the mountaineers climbers, what will happen, the climbers to become very weak and unable to think clearly. The symptoms of a condition known as anoxia. These are the symptoms of a disease, and this disease is known as anoxia, in which the people are very weak and they unable to think clearly. It means, what does it mean? It means since the solubility of oxygen gas in blood gets decreases, and as the solubility of oxygen gas in blood decreases, then the supply of oxygen in brain is also become less, is also get decreases. The supply of oxygen to the brain also get decreases, and it causes a disease which is known as anoxia. This is all about today's topic. Now, in our next video, we will discuss some numerical portion of that particular topic, that is Henry's law. We will discuss some numericals related to Henry's law. Now that's for all for today. Thank you.